You only need 2 phrases and 20 seconds to make ChatGPT answer 1.5 to 2 times stronger on almost any question. Do you think that sounds exaggerated? Or that this stopped working in 2026 because the models got smarter? It didn't. I'll show you on a real example. And I won't just show you. The same GPT will later compare both of its own answers and explain which one is stronger and why. Let's take any question. For example, what exactly do social media do to a person's attention, memory, and self-esteem? On the left, we simply ask that question as it is and get a normal answer. On the right, before that exact same question, we type or say the first phrase. Develop this into a full-spectrum prompt. And after GPT gives its first answer, we say the second phrase. Answer the prompt. And after that, the final answer becomes about 1.5 times stronger, deeper, and clearer. This is where the difference becomes clear. The answer on the left is decent. It gives a quick summary. Social media can make attention more distractible, memory more shallow, and self-esteem more dependent on comparison and feedback. It also notes that the effects are usually worse with heavy passive use. On the right, it goes much further. It separates attention, memory, and self-esteem more clearly, explains which kinds of use are most harmful, and adds the reasons behind each effect. So it is not just longer, it is fuller, clearer, and more useful. That is the real difference. The left side gives you a solid, direct answer. The right side gives you more context, more causes, and a more complete picture. And when GPT compares both answers, the gap becomes even clearer. The second answer is longer, more structured, and stronger in explanation, examples, and definitions. GPT's own conclusion is simple. Answer 2 is better overall. In plain words, this is a direct answer versus a much more developed one. Now we move to the same method in Claude from Anthropic. On the left, as usual, we use the exact same prompt and take the normal answer. On the right, we do something different. First, before the same question, we enter our phrase, develop this into a full-spectrum prompt. And then, after the question itself, we add prompt only. This extra instruction is needed specifically for Claude. Without it, Claude often starts answering the question immediately instead of building the intermediate prompt first. So here, we force the correct sequence. First, Claude generates the prompt. Then, after that prompt is ready, we enter the second command, answer the prompt. That is the full method for Claude. The logic is the same, but the handling is slightly different. On the left, Claude gives a normal, direct answer. On the right, it first builds a stronger internal structure for the task and only then answers it. And that changes the result. The upgraded answer is usually more structured, more deliberate, and more complete. It separates the key parts of the question more clearly, gives more context, and produces a more usable final response. So in Claude, the method still works, but here it needs one extra control phrase, prompt only. That small addition makes sure the model does not skip the intermediate step, and once that step is preserved, the final answer becomes noticeably stronger. Next, we apply the 2-phrase method to Google Gemini. On the left, a standard query produces a clean, accessible overview, touching on familiar concepts like the goldfish effect. However, on the right, we trigger the engineering flow. By asking Gemini to develop a full-spectrum prompt first, we force the model to adopt a multidisciplinary lens before answering. The result is a profound shift in depth. While the direct answer stays at the surface, the engineered response explores complex causal architectures, variable ratio reinforcement schedules, transactive memory, and the disruption of the default mode network. It even adds a functional digital hygiene framework for practical use. Quantitatively, the difference is staggering. This method captured 62% of the remaining performance ceiling that a normal query leaves behind, with a nearly 500% increase in explicit definitions. Comparative metrics show a method effectiveness of 65 to 75%, transforming a basic summary into a rigorous investigation. This is the ultimate contrast between a direct response and a systematically engineered response. With just 20 seconds of extra effort, you have successfully elevated Gemini to a professional research level. Next, let's apply the two-phrase method to Grok from XAI. On the left, we see a standard scenario, a direct question and a solid, fact-heavy response. However, on the right, we trigger the engineering flow by entering our first key phrase, develop this into a full-spectrum prompt. And then, after the question itself, we add prompt only. This extra instruction is needed specifically for Grok. Without it, Grok often starts answering the question immediately instead of building the intermediate prompt first. So here, we force the correct sequence. First, Grok generates the prompt. Then, after that prompt is ready, we enter the second command, answer the prompt. That is the full method for Grok. The logic is the same, but the handling is slightly different. On the left, Grok gives a normal, direct answer. On the right, it first builds a stronger internal structure for the task and only then answers it. And that changes the result. The upgraded answer is usually more structured, more deliberate, and more complete. It separates the key parts of the question more clearly, gives more context, and produces a more usable final response. So in Claude, the method still works, but here it needs one extra control phrase, prompt only. That small addition makes sure the model does not skip the intermediate step, and once that step is preserved, the final answer becomes noticeably stronger. Next in our research is the DeepSeek R1 model. On the left, a standard query produces a clean, accessible summary using a helpful table. It is a competent, high-level overview, but it barely scratches the surface of the underlying complexity. On the right, we trigger the true engineering flow. We start with our first phrase, develop this into a full-spectrum prompt. This command forces DeepSeek to abandon simple summaries and instead construct a massive, multi-layered architecture. It systematically unpacks the topic across 4 distinct thematic layers: mechanistic, neurochemical, temporal, and differential. This creates a comprehensive explanatory framework that looks at everything from the initial how to the long-term why. Once this deep structural blueprint is ready, we enter our second phrase, answer the prompt. The transformation is staggering. The resulting response delivers a far more developed and integrated causal analysis. It explains complex mechanisms like intermittent variable rewards, cognitive offloading, and even specific neurochemical pulse patterns. Quantitatively, the difference is undeniable. We see a 600% increase in section blocks and a 300% rise in explicitly named mechanisms. According to the comparative metrics, this method captured 78% of the remaining performance headroom that a normal query leaves behind. Method effectiveness reached an impressive range of 85 to 92%, driven by exceptional scores in architecture and explanatory quality. This is the ultimate contrast between a direct tabular answer and a systematically engineered response built on a layered causal architecture. Now, let's examine Qwen 2.5-Max from Alibaba. On the left, a standard query produces a solid, multifaceted breakdown of how social media influences us. It covers the familiar basics: dopamine loops, external memory, and comparison culture. It is a competent, clear response that easily satisfies a general user intent, but it remains fundamentally on the surface. On the right, we apply our method. We begin with the first phrase, develop this into a full-spectrum prompt. Qwen completely re-architects the task. It moves beyond a simple summary to create a research-grade framework, bringing in new dimensions like scientific insights, technological responsibility, and future implications. Once this blueprint is set, we enter the second phrase, answer the prompt. The jump in content quality is remarkable. We transition from basic description to deep causal analysis. For example, while the first answer briefly mentions reduced memory encoding, the engineered response explores the specific photo-taking impairment effect, explaining how capturing an image shifts cognitive focus away from actual sensory engagement. Instead of just stating multitasking is bad, The engineered answer delves into attention residue. It explains why rapidly switching between apps creates a lingering mental drag that actively degrades cognitive performance. It also adds a critical layer of technological responsibility, discussing how ethical design and algorithmic transparency can mitigate these exact psychological harms. Quantitatively, the difference is undeniable. We see a 100% increase in explicitly named mechanisms and formal definitions, alongside a 71% increase in unique themes. According to our evaluation, this engineered approach successfully captured over 31% of the remaining performance ceiling that the standard answer left untouched. This perfectly highlights the contrast between a direct response and a systematically engineered response. By investing just 20 extra seconds, you transform a basic overview into a professional scientific synthesis. We've now tested 6 AI models, generating 12 responses in total. Using their self-generated metrics, let's compare them. We aren't looking for a winner. Instead, we'll explore each model's unique focus, whether scientific, technical, or philosophical, and see exactly how this method unlocks their individual analytical depth. Just phone apps that make us sad. All neural networks synchronously reclassified them as a highly stimulating algorithmic environment that exploits our evolutionary biology. This unified semantic core manifested in a rigorous deconstruction of 3 main concepts: attention, memory, and self-esteem. First, attention. All models rejected the myth that social media simply destroys concentration. Instead, they described the slot machine effect. The AIs unanimously pointed to the mechanism of variable reinforcement and dopamine loops. The brain does not become dull, rather it is trained to constantly expect novelty, which leads to heavy costs when switching tasks and fragments our focus. Second, memory. Memory does not disappear, its mechanics change. All 6 models built their analysis around the concept of cognitive offloading. Social networks have become our external hard drive. The models unanimously described the photo-taking impairment effect. When we capture a moment to post it online, the brain refuses to encode it deeply. We begin to remember only where the information is stored, rather than the information itself. Third, self-esteem. All AIs agreed that likes and views have created the phenomenon of the quantified self. Self-esteem drops due to constant upward social comparison. We compare our real, imperfect lives with a carefully edited showcase of other people's achievements. Furthermore, a unified structural and tonal core emerged across all models. Upon receiving the command for a deep analysis, not a single AI slipped into moral panic or hysteria. They all used the cold, measured language of academic science. Moreover, each model deliberately introduced a layer of nuance, emphasizing that the effect is not linear and depends heavily on the user's age and whether consumption is active or passive. Finally, all the neural networks shifted the focus of blame. They pointed out that the root of the problem lies not in human weakness, but in the very design of algorithmic platforms. This core is our foundation. Now let's see how each of the 6 models pushed off from this base and revealed its own unique analytical architecture embedded by its developers. First is ChatGPT from OpenAI. Its main departure from the shared core is a manic drive for precision and preliminary classification. While other models immediately rushed to describe the impact on the brain, this model took a step back and built a definition layer. ChatGPT stated that social media cannot be analyzed as a single entity, strictly dividing it into 4 types: messengers, algorithmic feeds, short videos, and identity platforms. Structurally, its text is the most compact and dense. The model doesn't inflate the volume with fluff, it compresses meaning. Its tone is the voice of a dry, highly precise public health researcher who first agrees on the terms and then delivers a strict, modular clinical picture. Claude from Anthropic demonstrated a completely different vision. It took the basic neurobiological core and extrapolated it to the level of all humanity. This is the only model that went beyond the individual user and added a block on systemic and societal consequences. Claude analyzes how the fragmentation of attention among millions of people threatens democratic debate, distorts collective memory, and shapes new norms for entire generations. In addition, Claude showed unique intellectual honesty. It introduced a whole section critiquing the scientific studies themselves, pointing out the problem of correlation versus causation. In structure and meaning, it is a deep philosophical and sociological treatise, thinking on a civilizational scale. Gemini from Google broke away from the core toward practical utility and evolutionary psychology. It uses the most vivid metaphorical language, calling the smartphone our transactive memory partner. But Gemini's main distinction lies in its focus on the end user. After describing the problem, the model doesn't leave us alone with it. Out of all 6 neural networks, only Gemini concluded its analysis by implementing a strict, step-by-step digital hygiene framework. The model gives specific action protocols, such as batch processing notifications and the rule of delayed documentation of reality. Technically and humanely, Gemini acts as a strict but caring cognitive coach. Grok from xAI showed the most radical shift in register. It turned the response into a severe empirical meta-analysis, abandoning all humanitarian abstractions. Its distinction is a total reliance on numbers. Only Grok introduced sections for the empirical evidence base and measurements into its structure, operating with statistical concepts like Qwen's D effect size. It directly cites specific journals and study authors. Structurally, it is a rigid matrix. For each domain, it runs methodically through the exact same 8-point strict template. Grok lacks empathy. Its tone is absolutely cold and emotionless. It provides the user with a crystal-clear, indisputable evidence base. DeepSeek approached the task by deconstructing the structure itself. Instead of a linear answer about attention, memory, and self-esteem, it built a complex, layered architecture of causal relationships. The model divided the analysis into levels: mechanistic, meaning how it works; neurochemical, why we feel it; temporal; and differential. DeepSeek showed that these processes cannot be separated. Fragmented attention prevents the formation of memory, which in turn devastates self-esteem. Stylistically, this is a very deep cyber-psychologist. The model uses piercing metaphors, demonstrating a stunning level of understanding of how a person falls into an algorithmic trap. And rounding out our analysis is Qwen from Alibaba. Taking the common base as a foundation, this model shifted the focus toward the IT industry and the future. It's the only neural network that allocated a massive block to technological responsibility, directly discussing algorithmic transparency and developer ethics. Qwen looks ahead, analyzing the threats posed by the integration of artificial intelligence and virtual reality. But the most surprising difference lies in its humanity. At the very end, the artificial intelligence generated a personal reflection block, where it described a simulation of its own experience in the first person, what it's like to fight for concentration while scrolling a feed during moments of rest. This creates the effect of a live dialogue and makes Qwen the most empathetic conversative of the entire group.